Hello viewers, myself Dr. J. Abdul Bari, working as Associate Professor in the Department of Civil Engineering of K.S.Rangasamy College of Technology. Here we are going to discuss about basic concepts of mechanics and as well as the force system under the course Applied Mechanics. Before going to topic, we have to know about what is mechanics. Mechanics is a branch of science which deals with behavior of bodies which are all at rest or which are all at motions. Sometimes mechanics is also deals with the study of the forces and as well as the effects acting on the body. The forces may be of the internal forces or the external forces. The internal forces will be arising because of the internal effects acting inside the body, and it may be of the stresses and as well as the strain. The external forces has been arising because of the external effects acting on the body, and it is nothing but the study of the motions or study of the reactions. The displacement, velocity and accelerations will be coming as external effects which are acting on the body. We know very well the mechanics classifications as to three types as mechanism of rigid bodies, mechanism of deformable bodies and mechanism of fluids. So the mechanism of rigid bodies and mechanism of deformable bodies is coming under the mechanism of solids, in which the rigid bodies is nothing but study of external effects which are acting on the bodies. Whereas in the mechanism of deformable bodies, we are going to deal with the deformations which are all acting over the body, which has been again classified into two types as theory of elasticity as well as the plasticity. Whereas in fluid mechanics or mechanism of fluids, we are going to deal with various types of fluids like ideal fluid, viscous fluid, compressible fluid, incompressible fluid, and we are going to look after the properties of the fluid in mechanism of fluids. Coming into the engineering mechanics, the engineering mechanics has been classified into two types under the subheadings of mechanism of rigid bodies as statics and dynamics. Statics is study of the behavior of the body which are all at rest, whereas dynamics is the study of the behavior of body which are all in motions, and it has been again classified into two types as kinetics as well as the kinematics, where kinetics is the study of the forces without considering any effects on the body, and kinematics is study of the motion of the body by considering the forces acting on the body. Here we can able to see the rigid mechanics classifications as statics as well as the dynamics. So statics is study of the bodies which are all at rest. It deals with the equilibrium of the body under the action of the force, and the bodies may be either at rest or it may be moved with a constant velocity. If you are considering the body which has been given in this figure, the body has been seated on the chair. Here the resisting forces and the external forces and the self-weight of the body will be considered as the equilibrium of the particles. Like equilibrium conditions is summation of horizontal force 0, summation of vertical force 0 and moments is 0. Whereas in case of the dynamics, it deals with the study of the motion of the bodies, where we can able to find out the displacements, velocity as well as the accelerations. The engineering mechanics has been truly based on the Newton's law of motions. Now we will be seeing into the force systems. So if all the force systems lie on the single plane through a single point, then it will constitute a coplanar concurrent force systems. And it is possible to find out the single force which have the same effects as well as the number of the forces acting, and such a type of the single force you are going to call as the resultant force, and the process of finding that resultant force is called as a composition of the force. The force systems may be of the either push or the pull. Push is nothing but when you are going to give a compressive load on the body, that compressive load you are going to call as the push force, and when you are going to give the tensile load acting on the body, the tensile force you are going to call as the pull force. Simply, if you are dealing with the definition of the force, it is nothing but a capacity to do the work or any causes or physical change in the body. As per the Newton's second law of motions, we can able to say that force is directly proportional to the accelerations. So we can able to get the equation as F equal to m into a, where m is nothing but the mass or otherwise the constant of proportionality. Simply, a force is that which changes or tends to change the state of rest or motion of the body. Now we can able to see the composition of the force. The process of finding out the resultant number of the forces is going to called as the composition of the force. Consider P1 as well as the Q1 are the two forces acting at the point O, the resultant forces will be acting diagonal to the forces P1 and Q1 with respect to the angle theta. That resultant force can be found out with the help of the equations R equal to root of P1 plus Q1. And this process of finding the resultant force we are going to call as the composition of force. So the composition of force can be classified into two types, as analytical methods as well as in graphical methods. In analytical methods, we can able to look into the parallelogram law of forces, triangle law of forces, and resolution of forces. Whereas in graphical method, we can able to look after in polygon law of forces, triangle law of forces. Now we are going to see about the different types of forces. First, the collinear force. Collinear force is nothing but the forces which lie on the same line of actions. So it may be lie in the same directions or in the different directions. Consider this tug of war. If all the peoples are pulling each other in the same directions, it will be considered as the collinear forces. In another directions, in another figure, we can able to see two opposite directions the force has been applied. That is, tensile force has been applied. So that different directions, but the same line of actions has been occurred. So these types of force we are going to call as the collinear force. Next, we can able to see in the concurrent forces as the forces that do not act along the same line but do act through the same point. In general, the concurrent forces is defined as the forces that passes through a common point. That force you are going to call as the concurrent force. Also, in other words, we can able to see that a set of two or more forces whose line of actions interacts at the point at the same time is called as the concurrent force. In this figure, we can able to see that F1 and F2, the forces which are acting at the same point, the resultant forces will be of R equal to F1 plus F2. The forces are said to be concurrent if the points or if the line of actions intersects at one particular point. Similarly, if the forces acting at the different point, you can here see the F1 and F2 are acting at the different points where the resultant forces can be found out with respect to the equations of triangle law of motions like R equal to the same F1 and F2. In the third figure, we can able to look into here like the force F1 and F2 are acting in the different directions, and the resultant force R is nothing but F1 plus F2, which is also called as a triangle law of force. This force, that is Lamy's theorem, will also be coming under the concurrent forces. Here the forces F1, F2 and F3 are acting in the different directions, but it has been intersecting at the same point. If the body is in equilibrium under the action of the forces, each force is proportional to the sine of angle between the other two forces. This theorem is going to called as the Lamy's theorem. In the above figure, we can able to see that the force F1 is being proportional to the sine of the angle alpha. Similarly, the force F2 is proportional to the sine of the angle beta, and F3 is proportional to the sine of the angle gamma. So the equation can be written as F1 divided by sine alpha is equal to F2 divided by sine beta and is equal to F3 divided by sine gamma. Now we are going to see about the parallelogram law of forces. So this is applicable to determine the resultant of the two coplanar concurrent forces. Consider the forces P1 and Q1 which has been acting at the point O in a parallelogram OACB. Then the resultant forces will be acting diagonal to the parallelogram OACB. This states that parallelogram. So the parallelogram can be stated as if two forces acting at a point are represented both in magnitude and directions by the two adjacent sides of the parallelogram, then the resultant forces will be represented in magnitude and direction by the diagonal of the parallelogram passing through the same point. So as per the parallelogram law of forces, the resultant forces will be acting in the diagonal of the particular parallelogram, and it can be calculated if the forces P and Q are acting at the point OA and OB. Then the resultant force can be calculated with the help of the equation as P equal to root of P square plus Q square plus 2PQ cos theta. Whereas the angle between the resultant force and any one of the forces which has been acting on the OA or OB can be found out with the help of the formula tan alpha equal to q sin theta divided by p plus q cos theta. Thanks for your watching. Keep learning and keep growing. Thank you very much.